Hello everyone, this is our second video on queuing theory. In our last video we have learned how to solve a single server problem when the system was here m/m/1. That means the distribution of both arrival and service were Poisson distribution or logarithmic distributions, or another to say exponential distributions, okay, Poisson or exponential distributions. So here we have changed a scenario a little bit, okay. This is scenario 2. So scenario 2 means the system is going to have a change, So let us read the question, then we will discover what kind of system we are going to have now. Okay. So the first line says the inter-arrival time is exponentially distributed with a mean of 10 minutes. So distribution of arrival is m. There is no doubt over here. There is no doubt over here. Okay. And the value is lambda, which is again like before 1/10 because giving an inter-arrival time, so it is 1/10. But now from here, and the service time there is a difference here. The uniform distribution with a maximum of 9 minutes and a minimum of 7 minutes. Now in this question, they have described the distribution, okay. They have not just mentioned it is what. So we have to here understand what the distribution says here, and we have to find out the average of the distribution, and at the same time we have to find out the corresponding other requirement value. So let us understand this uniform distributions. If you have learned in the statistics, we have seen that this is our uniform distribution. If this is a uniform distribution, then the mean of this is a plus b by 2, and the variance of this distribution is b minus a square over 12. So this is the formula for the variance of this, okay. So naturally the service system is not m. I will name this as a g. For the system which is other than our exponential or Poisson distributions. So we have just now discovered that if the distribution is given like this, I first find out our mean and the variance. So mean will be here 7 plus 9/2, which is 8, and the variance will be here 9 minus 7 squared divided by 12, which will give me 1/3. So we have now discovered the distribution of this one. Now why I calculated this? Because when it changes from mm to mg, the formula for LQ is changed. And what is that formula? That formula is going to be here lambda squared sigma s squared plus rho squared divided by 2 into 1 minus rho. So here is the big change, okay, in the formula for the length of Q. The rest of the formula will remain same. Because they depend upon LQ and lambda, which will be given to us, okay. Mu also we can be able to find here. So the only change for the scenario 2 where this is m/g/1 system is that its Q length formula will be different, and it will be depending upon the variance that we have got over here. That is the reason why we found its variance. Okay, so we will be now trying to answer these questions, okay, according to our given informations. So what we have now, we already have got lambda is equal to 1/10. Now what is my service rate? So this is my mean arrival time here, okay? So the service time will be here, the mu will be 1 over, service rate will be mu, which is 1 over this number. So this is 1 over 8. So we have already got the two important information, okay? The arrival rate and the service rate. We have already got this, okay? So now, having got that, we will be now moving forward for solving this question. So mean number in the Q means LQ will now be calculated by putting the values over here. So I will be just cleaning this portion, okay, from here, and try to write down there. So this is now here. Calculation will be like this. Lambda is 0.1 square, sigma s square, which is the variance, 1 over 3 plus 0, and rho is 0.8 square divided by 2 into 1 minus 0.8. And this will give you an answer which is your 1.608. 1.608. So this is the average number of person waiting in the queue for service, which is 1.608 person. Okay, so this is your first answer. The next answer is what? The mean wait in the queue. So average wait in the queue will be what here? The average time in the unit spent for waiting. This is your WQ. So WQ will become here 1.608 divided by 0.1, which is 16.08. So you got here this answer, 1.608, okay, divided by 0.1 gives me here 16.08. So this is my mean time. So this is in minutes. So this is in minute. Okay. Next he is asking what? The mean number in the system. So I will be here calculating this one. This is your 16.08 plus 1 over mu is 8. So give me here 24.08 minutes again. And the proportion of time the server is number in the system. Okay. He also wants you to find the number in the system, this one, okay, this average time. He is asking mean number in the system, mean wait in the queue, mean number in the system is this one. So this is your time. Mean number in the system will be value of L, and this is simply here lambda time W, or this one, same. Lambda time W, which give you here 0.1 time. W is 24.08, so give you 2.408. So this will be given to you 2.408, and this is number in the system, these many numbers, these many people, these many persons. So here it was like this, okay, and this is over here, okay, this is over here. Okay, so we have got this all information. Then we want the proportion of time the server is idle. So it is 1 minus this one, which is your again same 1 minus 0.8 is equal to 0.2, which is 20%. When you say the proportion, so we will have to write in percentage. So this is our problem number 2. Problem number 2, when the scenario is changed, okay, from this service time has different distribution than exponential. It was the uniform distribution, and we learned one new thing, that if uniform distribution has the minimum and maximum value, I can find the mean and the variance of that distributions, and this will give me the value of the average value of the average service time of the system which is mu. So this was our second question. So let us stop it over here. It's already more than 10 minutes. So see you in the next video. Goodbye.